My name is TJ, and I'm happy to be here at Fluent, happy to be in San Jose also. It's kind of funny, I don't know much about San Jose. I've never been to this city before, ever. I knew exactly one fact about San Jose before like 2 weeks ago. That is that the San Jose Sharks play here. This is my entire worldview of the city of San Jose. So imagine my surprise when all I know is about a hockey team, right? And I step outside of an airplane to this, which is very much not hockey-like weather at all. But I know a little something about hockey because I am from the great, lovely state of Michigan, and hockey is one of the only things we have going for us at the moment, so we gotta defend these things somehow. In Michigan, we're not the biggest fans of San Jose because there may be some history, and we may be somewhat petty about sports rivalries in Michigan as well, because we also don't have much better to do. We also have some lovely weather in Michigan too, so in case I'm not selling the state hard enough, you should come and check us out. But in the wonderful wintry wonderland of Michigan, I work for a company called Progress Software. If you have not heard of Progress before, we are the company behind Kendo UI, which you might have used for web apps, web widgets. We are behind Telerik. If you've used Telerik tooling, maybe in your .NET apps, maybe in some of your mobile apps, Progress, we are the company behind that. And we are also behind NativeScript, our tool for helping you build native iOS and Android apps. NativeScript is where I come in. I've been a part of the NativeScript project now for about 2.5 years. I was actually at Fluent when it was in San Francisco 2 years ago to talk about NativeScript when it was then quite new, brand new. Of course, it's kind of fun to come back 2 years later and see how things have changed. People are now actually using NativeScript, which is a nice change for giving a talk on a topic. We've had quite a bit of growth with NativeScript in the last handful of months. If you are new to NativeScript, NativeScript is our tool for building completely open source, completely free apps, for building apps for iOS and Android. So what I'm going to do today is talk about NativeScript. We're going to start with some sort of higher level stuff about what is NativeScript, some of the high level concepts. And then we're going to spend most of our time actually seeing NativeScript apps in action. I think the best way to sort of get familiar with a tool, learn how to build a technology is actually to see it being used. So that's our topics for today. But I want to open up with some sort of higher level stuff about why you should care about any of this in the first place. And I want to start by talking about why you would even build a native app. NativeScript is a tool for building native iOS and Android apps. And in a way, it feels kind of silly for me. This is Fluent. This is a web developer conference. How many people would describe yourself as a web developer in this crowd here? So how many people would not, actually? So we got 3 or 4 people. So I am at a web developer conference and trying to tell you to build native iOS and Android apps, which does feel a little bit silly. But I do feel like you should have a good answer to this question of why you should build a native app. Especially if you are a web developer, building for iOS and Android is going to be harder than just building up another web app, cranking out another web app using the exact same tools you already know. There is a learning gap there. I don't care if you're using NativeScript, Ionic, React Native, building natively with Xcode and Android Studio. There's going to be more work. There's just no real way around that. Obviously, I feel NativeScript helps lower that barrier. That's one of the main reasons I am proud to be a part of the framework. But that gap is still there. There is some extra work to do. But I do think that there are some really compelling reasons to build those native apps. Even with the advances that the web has made that you might be hearing about at this conference, even with technologies like progressive web apps out there, I do think that there are some reasons that you still might want to build native apps. I'm going to give you 3 sort of lightning reasons here real quick, and then we're going to see those in action when I go to build an app here in a moment. So why build native apps? The sort of canonical reason that you hear all the time is related to performance. Things like you can do more in terms of how you can push transitions and animations when you're working in a native app, when you're working with bytecode. So these are the ones that come up all the time. I think these are a little bit, yes, you can push animations more in native applications, but it's sort of a superfluous thing. I don't think just because you want to do cool animations is like a reason that you should embark on a native app project. Yes, they are nice. The thing I think that's more pragmatic or that I see come up more often is when things related to lists. Anyone that's tried to build a non-trivial list on the mobile web knows that it can be a challenge, especially if you need to do rich templates, scrolling, pull to refresh, endless scroll, master detail lists. The more complex your list is, the harder that is going to be to build on the mobile web. And native platforms like iOS and Android have built-in controls to make these sort of things a lot simpler than they are in the web. You don't have to mess around with these virtual DOM techniques and these crazy JavaScript frameworks for implementing some of these basic list concepts. It's why a lot of really popular native apps, now companies that build these native apps, put a lot of effort into their native app development, even more so than their web development. If you think about it, a lot of mobile apps, a lot of the popular ones, are nothing more than big lists. I mean, what is Facebook and Twitter other than really a glorified large list? And being able to build a more robust list control can make a lot of difference for these companies in terms of higher engagement, higher user satisfaction, and such. Now, of course, you are probably not building Facebook or Twitter's next mobile app, but perhaps if you are working with a large data set, working with native technologies for dealing with lists and filterings and that sort of thing can help make your users more productive, your employees more productive, that sort of thing as well. So performance, I think, is one reason, but I think the far bigger reason that you should consider building a native app is if there's some API, some task that you need to do that you just can't do on the web, that the web just doesn't have that ability baked in. And I have a short list of things built in here. You can probably think of several other things that your phone is able to do that you cannot do on the web currently. I'll also mention that even on features where there's kind of parity between the web and native apps, that is, you can accomplish a task both on the web and in a native context, you can usually push native further. You can do more to customize the experience. So I'll give you a few examples. If you want to get a user's location, both on the web and a native app, that's something you can do. You can easily request a user's location. It's pretty simple. But on native, you can do more with that location. You can get the location in the background. You can do it in a pretty battery-savvy way. For instance, when I was walking around San Jose the other day, I got a notification from Google Maps, that I had to make a turn. This is possible because Google Maps can track my location in the background. Google Maps can also send me a push notification on iOS to let me know that I need to take some action. I'll give you one more. The camera, for example, you can take a picture on the mobile web. You can take a picture in a native web app as well. But on native, you can do more to just customize the camera experience. If you want to go crazy, you could bake Snapchat filters or some augmented reality thing like for a game, Pokemon Go type style application. But you can do just little simple things. I mean, I'm guessing all of you in here at some point have deposited a check with a banking app. So just that little overlay that you can put on the camera, I'm sure leads to far greater user satisfaction. I mean, I'm certainly happy that I don't have to go into a physical bank to deposit a check anymore. And just little things like that can really just build a more compelling user experience. You can also see these for like credit card readers, QR readers. There's a couple other examples of these sorts of things as well. So that's two reasons. The third one is just to try something new. For the same reason that you might learn a new programming language to sort of expand your horizons as a software developer, building a native iOS and Android app, regardless of whether you use NativeScript or any technology, is just a fun way to step outside of your comfort zone, give you just a new perspective at how you approach development, especially if you're getting in a rut doing the web over and over and over again. And using tools like NativeScript is a fun way to try native development without necessarily diving into the deep end. So, why would you use NativeScript to build these mobile apps? Basically because with NativeScript from the beginning, the reason we built NativeScript is to enable you to do these very same reasons you'd build a native app in the first place. We had performance in mind, and also we wanted to make it really easy to do these native things in NativeScript. And we also wanted to let you use tools that you might already use as part of your front-end applications to do this. So instead of talking about some of these things in the abstract, I'm going to switch over and show you a little bit of NativeScript in action, show just sort of what all of this looks like actually in practice. We're going to do a little demo here. I'm going to note two things before I dive into that, though. First, with NativeScript, we do give you some architectural choices in terms of how you build your applications. At its lowest level, NativeScript is just a technology that enables you to use JavaScript to drive a native iOS and Android application. So if you are interested in sort of a light dependency-free option of NativeScript that is available, we call it NativeScript Core. If you are a TypeScript fan, we have built-in TypeScript support that builds on top of that. And if you are an Angular fan, this being Angular 2+, I think our latest support is at Angular 4.1 or 2, something like that. You can use Angular as part of your apps as well. Angular was in the session title here. I will be using Angular for my demos, but pretty much all of the concepts I'm going to show relate exactly to building NativeScript with any of these options. Now, the second note is a little more fun. The demo is going to be about Pokémon, because of course it is. I am a 32-year-old man that's very comfortable in my love of the Pokémon world, as I think we can all somewhat agree. This is a picture of me 2 days ago at a fair in Santa Cruz. Totally won those two things at a little wiffle ball game. I know you're all pretty jealous of me right there. My significant other was very, very impressed. Happy to say I'm also representing the Red Wings, as I do, you know. I'm also a level 37 Pokemon Go player. I mean, not to brag or anything. For those of you that do not play Pokemon Go, basically being level 37 means that I make some very questionable use of my free time. There's probably more productive things I could be doing with my life. But the Pokemon world does lend itself pretty well to app usage scenarios. Both in the games and the shows and such, the character carries around this little device that tells them more information on the Pokemon world, Pokemon, what they are. Believe it or not, there's 802 Pokemon now, so lots of times you need an app to keep track of all this mess. So with that in mind, I am going to switch over to my demo here, and I've got to awkwardly find my mouse and switch off mirroring so that open display preferences. This is my favorite part of presenting, by the way. Arrangement, mirror displays. That didn't take too long. So here's my customized terminal, which you're probably going to be pretty proud of. So the first thing to know about NativeScript is a command line interface. So I can npm install NativeScript to get everything I need to do to interact with NativeScript applications. Once you have that installed, you have this command called TNS. It's short for Telerik NativeScript. It's a shorthand for doing all things related to NativeScript apps. I could use TNS create to actually build a new application if I wanted to do that sort of thing. I actually pre-scaffolded out an app here called Pokemon NG, just to save us a little bit of time so we don't have to go through all of those processes. So I'm going to bring up that application so you can see a little bit of what it looks like. The first thing I'll note is that because I mentioned earlier, with NativeScript, we're trying to use existing tools. All of our dependency management, all of our configuration in NativeScript is done using NPM. As I mentioned, I'm using Angular, so you can see I'm just bringing Angular in my package.json file. I'm bringing in a few NativeScript plugins, which I'll show off here in a minute. But again, these are things that you're probably already familiar with, concepts you probably already used during your front-end development. If you look in the app folder, which is where you'll spend most of your time for NativeScript app development, if you have done Angular work before, actually I should ask, how many people here have done Angular apps before, just to get a sense of the room? So it looks like about 2/3, 3/4 of people. So for those of you that have, this app is going to look a lot fairly familiar to the apps you would build as an Angular web app. You'll see some familiar file names like main.ts, app.module.ts, app.component. And really the same conventions apply in terms of how you name files, how you architect your apps, and that sort of thing as well. The one thing that you will miss, or that you will notice is missing, is that there is no index.html file. This is really the big difference when it comes to NativeScript versus building for the web, and also versus building with web-based native technologies like Cordova, like PhoneGap, and like Ionic as well, is that in NativeScript we are not using HTML, we are not using a browser, a web view, or a DOM in any way. We are rendering completely native iOS and Android user interface components. And this goes back to our focus on performance from earlier. We wanted to build apps that are really authentic and fit in with an iOS and Android ecosystem. Now for you as a web developer, this is both a great and a horrible thing. Now the good thing is you get an app that is an Android and iOS app. It's not styled to look like it. It actually is using user interface components. The downside is the learning curve when it comes to building NativeScript apps is in the user interface components that you have to use. Now, because we have to render these things out as completely native iOS or Android components, you do have to use the whitelisted, essentially, list of controls that we provide that render down into completely native iOS or Android controls. You can't, for instance, use a div or a span or that sort of thing as part of your template because, again, there is no browser, there is no HTML. We won't know how to render that sort of thing. But again, everything else here should seem fairly familiar. This is basically your Hello World Angular template, just with a slightly different control in here. And as you'll see in a minute, all the same sort of Angular isms, how you do data binding, how you do event binding, how you use services, dependency injection, all of those Angular concepts still apply equally in NativeScript. So there are a lot of things that you will be familiar with, especially if you have done Angular app development before. So I have this control. We want to see what this thing looks like. So I'm going to actually run this. Head back to my command. TNS run is how you actually run your applications. I'm building it for iOS in this case, so I'm going to be doing a Xcode build on iOS. It takes usually about 20 or 30 seconds to kick up since it's actually going through the native build process. Let's see, got to get my scaling right here. It's a really big iPhone. Let's see if 50% fits here. So the first load is going to take, like I said, 20 or 30 seconds. The good news is because we are using JavaScript, or in this case, TypeScript, any subsequent changes don't have to go through that full build cycle. Oh, I'm scrolling here. Here we go. So let's say I want to add some emoji to my title bar, because I often do. By the way, there's this macOS app called Rocket, which makes typing emojis super simple that I was using there. Pro tip. Gotta love that. You can see that that takes about a second or two to propagate over. So in this sense, NativeScript development is actually quite a bit faster than native development, because when you make changes, you're just making changes to TypeScript and JavaScript code. You're not going through that full native recompilation cycle. So this is a basic app, but of course, this is a Pokémon app. There are no Pokémon here yet, which is of course a big problem that we need to rectify. So what I'm gonna do is I'm gonna bring in a service. If you are familiar with Angular, services are sort of its way of just adding business logic to your applications. It's oftentimes how you interact with your data layer. In this case, this Pokémon service is just going to perform an HTTP call. It's gonna get some data for me. Now, I could implement this. With NativeScript, you can get your data from all the places you'd expect. We have plugins for things like Couchbase and Firebase and SQLite and a lot of other popular data providers that are out there. You can perform HTTP calls. Lots of times you can even share this service layer between your web apps and your mobile apps. This Pokémon service, for instance, is just using Angular's HTTP service, so there's no reason I couldn't just port this over to a web app and use it there as well. But this is simple. I'm just gonna get a list of Pokémon, so I actually have to use this. So let's go into my app component. I'm gonna add an onInit handler. onInit is Angular's way of just giving you a callback of when this component initializes, do this. And what I'm gonna say is go out to that Pokémon service, get me a list of Pokémon, and set it in this instance variable, this Pokémon list here. So I have to make TypeScript happy real quick. It wants me to import this onInit handler. And then I just have to come up with a way of rendering this. Now this is again where the learning curve for NativeScript really comes in, because I can't take, for instance, if this were a web app, I might have a UL and loop over and create LIs for each individual Pokémon. I'd probably bust out some CSS to actually style these things so I have a nice looking list of Pokémon that I can display to my users. That won't work in NativeScript, and you instead have to use our user interface components, which are gonna look a little something like this. So we'll work from the outside in. Scroll view, basically you can think of it as a div with overflow scroll. This area of the screen on iOS and Android does not scroll by default, so you need some user interface component to essentially tell it, you should scroll this area of the screen. In NativeScript, because things like display block, display inline block, and such aren't gonna work, there is no browser there, those aren't concepts that iOS or Android understand, you have to use one of our built-in layout components. We have things like stack layout, grid layout as well. But my preferred one, and since we have a lot of web developers here, probably your preferred one would be Flexbox layout. It's a layout system that we have that conforms completely to the web's layout specification. So pretty simple to use. And then in here, I'm doing a ng4 or a loop over these images. If you've used Angular before, this is a directive that just says, do a loop in this template. So what it's saying is spit out one image for every Pokemon in the Pokemon list. This is Angular's data binding. Again, I said in NativeScript, we're just using Angular's concept. Square bracket is just data binding in Angular apps. So I'm just binding to a property that's coming back from my service call. And I save this, and I don't even know if I can see this on this projector. So you might have noticed that we're not seeing any images here. Does anybody know why there's no images showing up? It's related to how Flexbox works, actually. So it's basically, Flexbox by default lays items horizontally, and it also doesn't wrap items by default. So what I'm doing here is I'm telling NativeScript to lay out 802 images and just straight in a line. And if the resolution is high enough, I don't even know if it's gonna show here, but based on my machine, iOS actually is capable of rendering this, which, believe it or not, is just like a couple tiny little pixel dots. But on this projector, I'm not able to see it, unfortunately. So how do we fix this? Well, in NativeScript, one other thing that we allow you to do is use a subset of CSS to style your user interface components. Now, I'll open up my app.css file. Now, this isn't CSS in the sense that you might think of it on the web. This isn't a file that you could take from, say, your web app and just dump this into the CSS file and expect everything to work. Again, we provide a whitelist of properties here because each and every one of these we have to be able to take from this file and apply to completely native iOS or Android controls. Like if you tried to apply a property to the action bar, it has to be something that we are able to set on a UI navigation bar on iOS or we cannot expose it. So we have a whitelisted set of properties that we list out on our docs that you can use. So all the big ones that you'd expect to work, things related to dimension, height, size, margin, width, color, background color, those sort of things all work. But some of the things, especially related to layout, like the display property, for instance, is not going to work, and that sort of thing aren't available. So in this case, I need to do a little bit of Flexbox configuration. So I'm going to tell Flexbox to actually wrap those images and add a little bit of spacing. And so now, yay, we have a giant list of Pokémon. And performs pretty well. I don't know how you can tell on this silly little simulator. You get some other built-in behavior, like on iOS, where I can tap the status bar to go on the top of the list, and silly little things like that. It is pretty cool. Like this isn't the world's most complex list, right? Like you could easily build this sort of thing as a web app, and it's no real big deal. But I will note that it is kind of cool that because this is a native app, like I don't have to care necessarily about spriting these images up because they're just a part of the application. It's just sort of no big deal. I don't have to worry about loading 800 images from the network. That's not a concern either. It's able to handle this fairly well. If I did want to make this list like a pull to refresh, maybe I was showing like a list of Pokemon in a game and you could potentially see if there were any new ones available. It's trivial for me to implement this. It's basically a Boolean that I could add to the list. I could make this into an endless scroll. That sort of thing is built in as well. So you have a lot of power in what you are able to do with these simple controls. I mean, this is what, maybe 30-some lines of code to put this together. And it's also an app that runs on native Android and native iOS. I'm going to switch over to Android here in a minute so you can see this running on both platforms as well. So that's one thing with NativeScript. As I mentioned before, you get some of these performant features out of the box. But as I mentioned, I think the bigger reason that you might want to build a native apps and the bigger reason that we built NativeScript the way we did is we wanted to make it really easy for you to tie into native capabilities on your device. So we're going to do a few fun things with these Pokemon that tie into essentially the APIs that iOS and Android provide. So we have some of these APIs built in. We have what we call the NativeScript core modules. They're 30, 40 APIs. Some of them are the user interface components that we've already used. There's things related to like connectivity, network, making HTTP calls, those sort of things that are available as well. But then we also have the NativeScript plugins ecosystem. This is plugins.nativescript.org, where we're listing out all the plugins that are available from the NativeScript world. There are a lot of things in here that you can drop into your app and get some pretty powerful functionality right away. So one of the things I want to do is use a plugin called text-to-speech, because even though I love the Pokemon franchise so much, sometimes I can't always remember the name of, say, like number 500 or number 600 randomly on the list. You could see this being a fun game, too, for anybody that just wanted to learn, get more familiar with the Pokemon world, quiz themselves, just being able to tap on a Pokemon and hear the OS speak their name. This is an API that's available on Android and iOS. It's sort of the same APIs that drive some of the accessibility features on the devices as well. So in NativeScript, because I already installed this plugin, I have my package.json here. I've installed the text-to-speech plugin. I've installed a couple other plugins as well that I'm going to use in a minute. We like the plugin ecosystem in NativeScript because it keeps our core fairly lean. Our core just does the things that we think are sort of essential to every application, keeps it fairly minimal, and that you can add on some of these more powerful functionalities if you need them as part of your apps. And so I've already got that installed. So what I'm going to do is import this here, bring in the text-to-speech plugin here. I'm going to next add a tap handler. So we're going to say when the user taps on this image, I'm going to invoke a function called onTap. This, by the way, is another sort of just Angular line of code. There's nothing here that's specific to NativeScript. The parentheses are how Angular handles event binding. When an event called tap is triggered, Angular will automatically invoke this onTap function. In fact, the only thing that's unique to NativeScript is just the name tap. It's an event that we're triggering. So essentially, we're coding to the iOS and Android APIs to detect that the user touched something. And we trigger this tap handler. And then at that point, Angular takes control from there. And actually, I need to add a $sign here, too. So on tap, we're going to call on tap. So I actually need to define on tap. So I'm going to go down into my component here. The text-to-speech plugin is pretty easy to use. You instantiate the thing and you just call it speak method. Pretty straightforward. And hopefully we get an app where we hear Pokemon name now.
Bulbasaur, Charmander, Squirtle.
It's amazing how much time you can waste on these sorts of apps. And we're just getting started, by the way. So personally, I think that voice sounds kind of slow, right? Like that was a little bit weird. So this plugin has some nice TypeScript configuration here. So I can change things like the pitch and the speak rate. So I'm going to do that, and we'll see if that sounds a little bit better. Get a drink real quick.
Bulbasaur, Charmander, Squirtle, Butterfree.
So this is pretty cool, right? And really, although this example is somewhat silly, this is kind of the value proposition of NativeScript in the first place. Like, you're using, this text-to-speech plugin is written with completely native iOS or Android APIs. It's hitting something that's built into the device. But this is pretty transparent to you. Like, you don't have to care. You installed a plugin through NPM, you imported a single class from that plugin, and you called a single method, and you're able to tap into some pretty powerful functionality, some pretty useful functionality as well. So that's text-to-speech. So that's the first plugin I'm going to show. I've got another batch of plugins ready, though, as well. And to show those, we've been doing iOS to this point. So I'm going to head back over here and run this app on Android, just so you can see that all this code is completely, there's no iOS or Android calls in here, right? Like, all of this is completely cross-platform stuff. You can in NativeScript if you'd like. We have ways of branching your code. If you do want to provide, let's say, different templates for Android or iOS, there's certainly cases where you might want to do something a little bit different. If you wanted to do different CSS for Android, iOS, or even if you just wanted to do an if check, we have those things built in. But for the most part, I think for your average app, I'd say 90% of what you're able to do is pretty cross-platform, as you're seeing in this fairly simple example. Android emulator takes a little bit longer to start up. Android is not necessarily known for its fast boot times, for better or worse. And so with NativeScript, because we're using those tools, we feel that pain as well. Usually it takes about a minute. But like iOS, you'll see the same. Once this app gets loaded, that initial time, we're able to make those changes pretty well. I think the voice on here is actually, I haven't used this one yet. We'll try to see what the Android voice sounds like.
Bulbasaur,
Oops,
Charmander, Squirtle.
If only you knew how much time I spent just playing with this silly app. So text-to-speech, pretty cool, but I think we can do more. The plugin I want to use next, just to give you an idea of where this demonstration is going, we're going to use a plugin called Explosion Field. So you might be able to guess ahead where I'm going with this. So we're going to head back here and actually bring in a few different plugins because I want to do a few different things. I'm going to bring in a plugin called Fancy Alert. It's just wrapping an iOS and Android library that just lets you do some nice-looking alerts out of the box that just don't look like the stock alerts and dialogues that are built into the OS. I'm going to use an audio player. We're going to play some audio. Some of you that were in this room a little bit early got a little bit of preview of where that is, of what that's doing. And we're going to make some things blow up too, specifically Pokemon. So we've got our list here. The first thing I'm going to do, I brought in that Fancy Alert dialog, so I want to show a Fancy Alert, because if you have a Fancy Alert plugin, you should probably put that to use. So let's go ahead and show a little plugin. I also find it amusing, by the way, how well these native OSs just support like built-in emoji rendering too. That's something that just fun fact that just amuses me. Let's see. So now I should show a warning when I show up there. So Bulbasaur is about to blow up, right? We should give the user fair warning before we go down this path, because it's going to get pretty dark in this room here in a minute. So we showed our warning, and now let's just go for it. We got our Pokemon, and the Explosion plugin is pretty easy to use. It's just got a single method. It's called explode, and you pass it the thing to explode. It's good API design right there. So now we're going to show our warning, and we're going to actually explode the Pokemon. This is where the real fun comes in. So we're going to go back here and do this. Venusaur is about to blow up. This is oddly amusing for me. The last thing we're going to do too is, okay, so we've got exploding Pokemon. We've got a warning, but I brought in the audio plugin as well. So we're going to add a little effect to this also. So I'm going to go down to my on init handler. The way the audio plugin works is you have to initialize the thing, give it a sound file you are going to play, called mine boom.mp3. And what we're going to do is after this happens, I'm going to say this.player.play. We're going to play our sound file. And hopefully we'll create a nice experience here for our user. Let that load up. And here we go. Oh, what went wrong? Maybe that sound file I didn't finish. Oh yeah, there we go. So there you go. The practical things you can build with NativeScript. But, in all seriousness, this demo is kind of silly, right? Like, I don't think you're going to go back and say, like, yes, go to your company, walk in your boss's office and say, hey, I got our next corporate strategy. We're gonna bust out all these plugins. But the point I'm trying to make is just the sort of system that I'm using here, right? Like the ease of just bringing in a single API here and then just using it for a very straightforward API. And even though this application I'm building is somewhat silly, just to have a little fun today, you can use these to build some really powerful, really compelling applications. So just to give you an idea of this, my colleague Jen Looper is using the audio player for an app that's out in the stores called Practice Buddy. So it's an app that will be for music teachers and music students, where the students can record themselves playing, practicing their instruments, send them to their teachers. Their teachers can then listen to that as part of the application. It's a pretty simple app. It's built with Angular, and it makes use of this NativeScript audio plugin as well. There's some other serious things you can do. For instance, does your app need to take money? Well, there's a PayPal plugin that you can use to do that. There's a Stripe plugin that you can use to do that. There's an in-app purchase plugin that you can use to do that. Does your app need to authenticate users? Lots of apps have login screens. Well, there is a fingerprint auth plugin that you can use to give yourself users Touch ID, and then I don't remember what the name of it is on Android, but it supports Android as well. There's an OAuth plugin, if I can type it. There it is. There is a Facebook login plugin if you wanted to add a Facebook interaction to your application. There are also some more business-friendly things like if you needed to add charts to your applications, if you needed to add graphs, grids, those sorts of things, they are available as well. And to switch back over here to let's see, where's my presentation? Oh yeah, it just worked. So we are seeing more of a push from NativeScript in the business world. We just had SAP announce that they are using NativeScript as part of what they call their enterprise app modeler. And so we're starting to see more things like this come in with NativeScript because of its ability to meet these sort of business use cases like these sorts of things. We also have enterprise support for NativeScript and developer support as well. So if you were also wondering, since we're a company behind this, how do we make money off of NativeScript? We sell support to large organizations that are looking to standardize on NativeScript. So if you're interested in that, just Google NativeScript support and check that out. So hopefully, whether you are using NativeScript to build the next Pokemon exploding app or just the next app that helps your marketing or sales teams internally, hopefully you find something that you could use. If you are interested in anything you heard today and want to learn more, the best ways to keep up with NativeScript is either the NativeScript newsletter. You can just Google NativeScript newsletter. It's a monthly email that just tells you about the latest and greatest to do with NativeScript. You can follow NativeScript on Twitter. That tends to be our most sort of up-to-date place where we talk about things that are happening in the NativeScript ecosystem. If you are interested or if you want to learn more about NativeScript, actually want to go through a full tutorial, the best place to get started is heading to nativescript.org. Click the big green Getting Started button. We have a series of Getting Started tutorials that will walk you through from sort of step one to everything you need to use the frameworks. And finally, to give you one last plug, we are sponsoring this event at Progress, and we have swag. So just to give you an idea, there are NativeScript stickers up here. You can come grab one from up here. We have NativeScript stress balls, which are pretty fun. You can grab one of those. And I think the real clincher is we have NativeScript socks. So make sure to find our booth in the area, and we'll hook you up. So if there are any questions, if you want to chat about NativeScript further, something specific that you have in mind or specific questions, just come find us. I think we have a few minutes for any questions that may come up. Yeah. So the question is, do we have something similar to Ionic View? So Ionic View is Ionic's app where essentially it's an app you download on your phone and you can just sort of preview the changes. And the answer is coming soon. If you Google NativeScript Sidekick, you can find some information. So stay tuned for some tooling we have coming in the next few months. Yeah?
Is Angular the only Vue library you support?
So the question is Angular the only Vue library that we support? At the moment, yes. We are in early stages of working with Vue. We're sort of in an experimental stage there. Like it's largely a community-backed effort. So we're sort of evaluating where we want to go with there. NativeScript is sort of a framework, can support any arbitrary framework. It's really just low level, just lets you write JavaScript to run applications. The challenge is from a maintenance perspective, like if we enable Vue, it's committing to the documentation and the maintenance and making sure all of that happens. So we're gauging demands at this point, and then we'll go from there. Yeah?
How do you compare yourself with React Native?
Yeah, so the question was, how does NativeScript compare with React Native? At a high level, sort of if you were grouping frameworks, NativeScript is certainly the most similar to React Native. React Native takes a similar approach in that they are using native user interface components. They are not using web-based tooling. I would say the biggest difference between us is just in terms of how you actually build your apps. So with NativeScript, you can use Angular, for instance, if you are an Angular fan. You can also use this with just raw JavaScript. If you are the type of person that doesn't want to use any frameworks, you want to keep things slim, we offer that as well. The second thing I would say is if you are a company that's looking for more support options, we offer that sort of thing as well. We have those things that are available. Yeah?
Do you support having like separate config files for something like the text-to-speech and saying in Android you need these values, in iOS you need like separate code bases for those?
Yeah, so the question was like if you wanted to configure the text-to-speech plugin, do slightly different things on iOS and Android. I'd say the easiest thing, like in that situation, I would just do like a simple if check. Like there's like a variable, like you could say basically if iOS use this value, if Android use this value. For bigger changes, like we do have ways of, for instance, you could say it's your template file, like I wanted to, if iOS load this template, else if Android load this template, if you wanted something a little bit crazier. And if you look in, I didn't really get into how plugins are actually written or how the NativeScript source code is actually written. And we do have a convention where you can just name something .ios.ts, for instance, or .android.ts if you know the implementation is going to be completely separate. So if you looked at like the text-to-speech plugin source code, you would see a bunch of Android code in one file, a bunch of iOS code in the other file, but they're both exporting the exact same API so that the user of the plugin codes to one thing. Any other questions? All right, well, thank you very much. Make sure to stop by, grab some swag and such.